Alright guys, so today we're going to be looking at section 7.3. This is all about simplifying rational expressions. Rational just means fractional. And the numerator and denominator are non-zero polynomials. Polynomials are just like x squareds and things like that. I can multiply and divide rational expressions and state restrictions to keep expressions equivalent. This is going to be the hard part for you guys, is these restrictions. And the reason why is because you haven't had to do it before. In Algebra 1, you did some simplifying of rational expressions, but you never had to worry about restrictions. So that's going to be our goal on this. So the simplified form of a rational expression is a rational expression with no common factors other than positive or negative 1. So if we look at a number like 12 ninths, if I'm trying to put that in lowest terms, I have to think of 12 as 4 times 3, 9 is 3 times 3, cancel the 3's, and then our answer is 4/3. Well, if you think about it, a lot of times people want to cancel terms. Here's what I mean by terms. Let's say I decide to write 12 as 9 plus 3. That's equivalent, right? And then I have 9 in the denominator. So if I just gave you this problem without you knowing it was equivalent to that, I've seen people do this. They're like, oh, I'm going to cancel those. I get 1, so it's 4. No, absolutely not. These are called terms. You cannot cancel terms. You can only cancel if it's a multiplication situation. So don't do that. All right, 15 over 65, that's 3 times 5 over 13 times 5. The 5's will now cancel because it's multiplication. And so 3/13. All right, look at this one. We started with 4 times x plus 3 over x plus 3, x plus 3. Well, I can cancel out these two because they match. I don't cancel out both. It's just 1 for 1. And then I have 4 over x plus 3. Now, here's where it gets different from what you're used to. Most of you could do that, no problem. However, think about this. If at the beginning x had been negative 3, if x had been negative 3, this would have been 4 times negative 3 plus 3 is 0. Negative 3 plus 3 is 0. And this is 0. I would have gotten 4 times 0 is 0 over 0. This is something that's called indeterminate when you get into higher level math. However, in my new answer, if I plug negative 3 in, I have a 4 on the top. Negative 3 plus 3 is 0. So in this case, I get something that's undefined. These are two different answers. Therefore, I can say that 4 times x plus 3 over x plus 3 times x plus 3 is equal to 4 over x plus 3, but only if x is not equal to negative 3. And that's because of what I just showed you. 0 over 0 and 4 over 0 are different. So therefore, because we got rid of this x plus 3 right here, we have to say x cannot equal negative 3, or else they are not truly equivalent. Let's look at another example. Simplify 5x plus 25 over x squared minus 25. State the restriction for which the new expression is not equivalent to the original expression. There will be only one value for the restriction. Use the table feature of your graphing calculator to see why the restriction is needed. All right, so I start off with my original function, and I have to create factors out of it. So I say, okay, these can be divided by 5, so it's 5 times x plus 5. The denominator is the difference of two squares. That's x plus 5, x minus 5. That's something you need to recognize immediately. These two now cancel, and so I'm saying the answer is 5 over x minus 5. But is this truly equivalent to the original one? We got rid of this factor. What makes this factor equal 0? What plus 5 is 0? Negative 5, right? So think about it. Way back here at the beginning, what if x is equal to negative 5? What's going to happen? Well, I get 5 times negative 5 is negative 25 plus 25. Negative 5 squared is 25 minus 25. That's 0 over 0, right? So that's what I would get at the beginning if I sub in negative 5. What do I get here, though, if I plug in negative 5? Well, I would have 5 over negative 5 minus 5 is negative 10. That's negative 1/2. Those are completely different answers. So I say this is equivalent to the original, however, as long as x is not equal to -5. Because if x is equal to -5, they are not going to be the same thing. I'm going to show you how to do this. All right, so what we're going to do is we're going to put in that original function. Here's a quick way to do it. Do alpha y equals, and you get this n over d. I like this. So you can do 5x plus 25 over x squared minus 25. That's how I can put in a rational function. If you have an older calculator, I'll show you how you'd have to do it on that. The older ones, I don't think they have this second, or this alpha y equals. So if I want to put this one in the old way on an older calculator, I do 5 divided by parentheses x minus 5. That's another way to put it in. You have to put the top in parentheses and the bottom in parentheses, but this is just one value. All right, so now we're going to look at the table of values, second table. All right, so here's what I want you to look at. In order for these to be equivalent, they have to have exactly the same values. All right, I want to do something because I want these to show up as fractions, just so it makes more sense to you.
Would William Akindelli, if you're in the building, please report to the main office. William Akindelli.
All right, so here's our original, here's our new one. We're going to look at the table again. Now it's going to give it to me as fractions. See how they match up exactly. Everywhere they're matching up. Even here at 5, they match up. They both have errors, right? So they match up. But watch when I come back here. -5. Uh-oh, look at this. The first one has an error, and that's because of that 0 over 0. Whereas the second one has an answer of -1/2 for -5. So the only way my y1 and y2 are equal, they're equal everywhere, except for at that -5. So that's the reason I say this is equivalent to this, but not if x is -5. They would not be equivalent then. All right, so let's keep going with this. So, multiplying rational expressions. Let a, b, c, and d be expressions with b not equal to 0, d not equal to 0, meaning it's not undefined at the end, at the beginning. To multiply, you can multiply straight across, a times c, b times d, and then simplify if needed. So look at this example. They give us 5x squared over 2xy squared, 6xy cubed over 10y. Multiply straight across. Here's what you get. Now they break this up. 30 is 10 times 3. 20 is 10 times 2. The reason they wrote it that way is they want that common factor of 10. X cubed, they wrote as x times x squared because of that x there. Y cubed and y cubed are exactly the same, so they just keep it like that. Anything divided by itself is 1. And so what we're left with then is 3x squared over 2. But look at this, guys. Look at the domain here at the end. There's no restriction because the only thing we're not allowed to divide by is 0, and we're never going to divide this by 0. But look back here at the beginning. At the beginning, the domain is x cannot be 0, y cannot be 0. So at the beginning, we had this domain where this wouldn't even be defined if x is 0 and y is 0. So because of that, that's going to be our restriction. This is only equal to this one if x is not equal to 0 and y is not equal to 0. Because look, if I plug 0 in here for x and y, I get 0 over 0. If I plug in 0 for x here, I get 0 over 2. That's just 0. That's different than 0 over 0. I can't even plug y equals 0 in here because there's no y. So this would just be 3x squared over 2 when y is 0. But this one was 0 over 0 when y was 0. So that's the reason for this answer, okay? It can be a complicated concept, but once you kind of figure out that pattern, it must be equal to the first one in all situations. And this is equal, but not in those two situations. All right, let's look at this one. So this is just a single expression. I cannot cancel these 4s. Those are terms. I can't cancel the 12 and the 4. Those are terms. Don't do it. I have to have factors. To factor the top, I'll just rewrite it first. The top is going to factor into x and x. Numbers that multiply to be 12 and subtract to be 4 are 6 and 2. I need a negative 4, so that's negative, that's positive. Difference of two squares is x plus 2, x minus 2. Okay, now I have to, the easiest way to do this is now to look at my domain. Here my domain is x cannot equal negative 2 and x cannot equal positive 2. All right, now I'm going to simplify it. Boom, boom, gone. So my answer is x minus 6 over x minus 2. So now I'm thinking of my new domain. X cannot equal 2. Well, okay, I know that. Sorry, that should be cannot back here. So x cannot be 2 here. I already knew back here x cannot be 2. But for this one, I don't know about this x not equal to negative 2. So that's the one I have to use. X cannot equal negative 2. See, look, back here, if x is negative 2, I'm going to get 0 over 0. But if x is negative 2 here, I'm going to get negative 8 over negative 4. I get 2 for my answer. So negative 2 back here and back here gave me 0 over 0, but here it's going to give me 2. So I say these two are equivalent, but as long as x isn't equal to negative 2. All right. Dividing rational expressions. To divide values, a over b divided by c over d. The first fraction stays the same. We multiply by the reciprocal of the second one and just multiply straight across. Simplify if possible. Let me start by doing this with numbers. What about if we've got 2/3 divided by 1/3? All right. Well, if I'm doing that, I'm going to do 2/3 times 3 over 1. Now those can cancel, and the answer is 2. Okay? If I divide 2/3 by 1/3, I'm going to have 2 items, right? Dividing it up into 1/3. Let me go to the home screen. I want to show you a common mistake. People do this problem. They do 2/3, and then they say, okay, I want to divide that by 1/3. Oh, you can't see that. Hold on. Let me start over. 2/3 divided by 1/3. The answer has to be 2. Look, wrong answer. Here's the reason why. You have to put the 2/3 in parentheses. 2/3 divided by parentheses 1/3, and now it'll give us the right answer. Or I could use that cool thing I showed you earlier. Alpha y equals, get the fraction, 2/3 divided by alpha y equals 1/3, and it gives me the right answer. Okay? Make sure you, whenever you're taking that ACT, make sure you do that. Put parentheses around your fractions if you're multiplying or dividing. Or just use that alpha if you have a new calculator. All right, let's look at some division problems. We have 7 over x plus 1 divided by this. So the first part stays the same. We take this, we flip it over, and we change it to multiplication. You can combine these all together now if you want. And you have to look and see if you can cancel anything, and you cannot. But we still have a restriction, because back here, at the very beginning, x cannot equal negative 1. X cannot equal 3/2 at the beginning for our domain of this, right? But back here, we see that x can't be equal to negative 1. That's the same, right? So that's okay. But I can't see that x can't be equal to 3/2. So that's the reason we have to state it, even though it didn't cancel out anywhere. See, back here, if x had been 3/2, I would have 7 over 0 divided by, if I plugged in 3/2 plus 2, 3.5 divided by, and 3/2 would have given me 0. And that doesn't even make sense, right? But on this one, if 3/2 is the value for x, I'm just going to get 0 on the top. And I would just get 0 divided by some number. So that's going to be different. So even in this situation, whenever that domain is changing from here to here, I have to write it as a restriction based off of that original. Because this domain, x can't be negative 1, we see it. x can't be negative 2 now, but we don't have to state that, but we can't see that x isn't allowed to be 3/2 from that beginning part. All right, let's go on down to this one. We've got x times x plus 1 over x minus 2 divided by x. Oops, I don't want to rewrite the problem. Let's change it to multiplication right now. Here, just make this times. Times, and I'm going to flip it. X minus 6 times x minus 4 over x times x plus 1, x minus 6. I have to look at restrictions at each step. At the beginning, x cannot equal 2, x cannot equal 6, x cannot equal 4. Okay, now at this step, x cannot equal 2, x cannot equal 0, x cannot equal negative 1, and x cannot equal 6. All right, now we're going to find our simplified answer. Let's see here. X plus 1's cancel, x minus 6 cancels, x's cancel. And so my final answer then is x minus 4 over x minus 2. So now I can see x cannot be 2, right? So I don't have to write that. I don't have to write x cannot be 2, but I got to write all the rest of this. I got to say this is equal to the original as long as x does not equal 6, x does not equal 4. Oh, we already know x can't be 2. X cannot be 0. X cannot be negative 1, and I already said x can't be 6. Now it would be equivalent, as long as x doesn't equal any of those numbers. Okay? So we had to look at the restrictions at each step, and then we figure it out at the end. What should be those restrictions? I don't have to say x can't be 2, because back here it was undefined, here it was undefined at 2, here it's undefined at 2. All the answers are the same. But if I plug 6 into this, I'm going to get a nice answer of 2 over 4. Well, that's not what I would have gotten back here. I would have gotten something undefined. And here it would have been undefined, etc. All right. Doesn't matter if the numerator is 0, just the denominator. Okay, let's try some of these. In exercises 1 and 2, simplify possible state restrictions. All right, so on this one, I look at what I can factor out. I can factor an x out. I can factor out a y squared. Then I'm left with a 5y minus 2x, okay? And then in the denominator, I've got x squared, y squared. So the y squareds go away completely, and I have 1x left on the bottom. So here's my answer, 5y minus 2x over y. So in this one, I can see y cannot be 0. But back here, x cannot be 0 and y cannot be 0. I can already see y can't be 0, but I can't see that. So I'm going to have to say x cannot equal 0. Guys, you should pause the video, try these on your own. You have to be active with your learning. Watching me do it does not help as much as you doing it on your own. All right, let's look at this one. In the numerator, I can factor out an x squared. I'm left with x plus 3. In the denominator, I'm going to have x minus 8 times x plus 3. All right, now these two are going to cancel. My answer is x squared over x minus 8. But I got rid of this, and it would not be equivalent. I have to state that. I have to state x cannot equal negative 3. Because at the beginning, this was not defined if x was negative 3. It was that indeterminate I told you about. Whereas this one would have an answer of 9 over, what, negative 11 or something. Okay? All right, at this point, you should pause and then come back and check your work. See if you can figure all these out with the restrictions. Okay? I'm going to be doing them, and I'm going to be doing them quickly because you're just going to do these on your own and then check. So I can see x cannot be 0, but I can't see that, so I got to state it. On this one, I got a factor. You know how to factor that. You should have already worked these. I'm just going through it quickly. Is that it? Yeah. Seems like more should go away, but that's it. All right, so let's see then. Back here, x could not equal -1, and we can't see it here, so that's our restriction. Get it right? All right, let's try this one. Factor the numerator. Oh, cubes. Do you guys remember how to factor cubes? Here's how it goes. I'll write the formula up here in case you forgot. It's a cubed plus or minus b cubed equals, see if you remember it, a plus b, and it's actually a plus or minus, and then it goes a squared minus or plus ab plus b squared. Important formula there. So for ours, we're going to do a plus 2 x squared minus 2x plus 4. By the way, these will never equal 0, which is handy. Down here, I'm going to factor out an x, and I'm left with x squared minus 4. Okay. I got to keep going with this. I'll show you why. This can never factor down further if you do a cube, unless you forgot a GCF at the beginning. This is x plus 2, x minus 2. All right, so I'm going to look at my domain back here before I go. I know x cannot equal -7, x cannot equal 0, x cannot equal -2, x cannot equal +2. Okay, that's all the restrictions at the beginning. We'll see what happens here. Nothing goes away with that. Those cancel. All right, so our answer then is x squared minus 2x plus 4 over x plus 7. However, all of these I can't see. I can't see that x could not equal 0. This one's defined for that. It's 4/7. I can't see that x isn't allowed to be -2. Back here, -2 is undefined. But now, -2 would have a nice answer. And also, x cannot equal 2. 2 right here is 4 minus, would be 4 over 9 or something. So we've got to make sure we state that. This is equivalent to that as long as x isn't equal to any of those. All right, keep going. If you haven't paused the video yet, you better pause it now and try this on your own. Active learning.
Adam Meyer, please call 10408. Adam Meyer, 10408.
All right, so at this point now, actually I want to look back here too. I already flipped, but back here at this step, when this was in the denominator, x could not equal 3, because these were really in the denominator. X could not equal 1. Okay, now I've got new things to add on. What else? Oh, I should have seen that at the beginning. X cannot equal 2. X cannot equal 0. X cannot, I already said 1. X cannot equal -1. All of those restrictions. If I don't see any of those at the end, I better state it. Let's see here. What cancels? That and that and that and that. It's kind of like a puzzle or something. Okay, here's my answer. X minus 3 over x minus 2 is equivalent to this, but, okay, I can see x can't be 2, so I can get rid of that one. But I got to say all the rest of this. Okay.
If there are any wrestling coaches in the building, can they please call 10408?
Except for in those cases. Because look, if I plug in 3, I get 0 over 1. But back here it would have been undefined, right? Right here it would have been something undefined. All right, on your own, that's what OYO is. So you're doing this one on your own. Check your answer when you're done. Oops. Hopefully you're getting faster at factoring. Just double checking. No, looks good. Okay. So back here then, I already flipped because I did times the reciprocal, but back here, this would have been on the bottom. So x was not allowed to be -9, x was not allowed to be 8. Over here, I already said 8, x could not be -5. And now in this step, x cannot be -9, already said it, and x cannot be 1. All right, I'm going to keep going. All right, so our answer then is x minus 3 over x minus 1. I can see x can't be 1. I don't need to state that because that was undefined at the original and it's undefined here. But I will have to say x cannot equal -9. Because back in here it would have made it undefined, but here it would give us nice answers. So not equivalent under those circumstances. All right. Hopefully you did pretty well with that.